Hey, 8th grade. So I know I had some questions on the components of the universe unit. At this point, you should have all of your tides assignments done and complete. Don't move on to any of the components of the universe stuff until all of your assignments on tides are complete, okay? You can check your grades on STEMscopes and it'll have a whole list. It'll tell you what you got. If you notice that I reassigned one to you, again, that is because you did not get a passing grade, so I reassigned it to you so you could get a passing grade. It's just like normal, just like class, okay? But as far as the components of the universe are concerned, one of the biggest things, I guess, that we need to talk about is all of the terminology, okay? Because I know there's all these new words out there that kind of sound familiar, like, again, a star. We've all heard that word our whole life, but what is it? You know, what truly is a star? What does that mean? So you'll see that the Hertzsprung-Russell diagram from Mach star is in this unit. Basically what that is for, it's to show the current place, okay, the current place of where a star is. So it can move, you know, across time. It can move from category to category. So our stars have a bunch of different categories. And if you look on the PowerPoint that I posted, there is a chart, I guess if you want to call it a chart, and it's the life cycle of a star. I would save that to your computer, or I would hand copy it, write it on a piece of paper. If your parents have access to a printer, that would be great. Print that out and keep it somewhere, please. Because that is probably going to be your biggest helper for this class as far as the categories of how stars are broken down. Now, the Hertzsprung-Russell diagram, it's kind of weird the way it's actually set up, because if you look in the middle, that's where we have, again, 0 for luminosity. And then you have, again, above it, everything that gets brighter, and then you have everything below it, which, again, it's not as bright. That's all it means. It's kind of like when you look at light bulbs and they have different wattages, and again, some are dimmer, some are brighter. It's kind of the same idea. So it's not that because they're at the bottom of the luminosity, they are not emitting light. Okay, they are still emitting light. It's just not as much as this category up here at the top. And then when you look at the temperature, you know, when we're used to looking at temperature on graphs, it's usually 0, kind of at that middle point, that intersection of where our X and where our Y axis meet, you know, that's usually 0, and then it gets bigger going across. It's actually the complete opposite with this Hertzsprung-Russell diagram, where the temperature on the right side is as cool as it gets, and then as we actually move inside towards the graph, that's actually where it gets hotter. So please make sure you're paying attention to that, because you will have an assignment later on in the week where you're going to have to use that diagram to answer questions. So I really want you to just study it for right now, and I want to make sure everyone is understanding the vocabulary for this unit, and then I'll assign it later when I know that everyone kind of has a basic idea. I am still waiting for certain people to get caught up because, you know, they barely got a laptop and things like that. And again, that diagram that we're talking about, if you look in that corner, okay, where you have your y-axis and your x-axis, right here in that little corner, that's where your white dwarfs are. So you have stars in different categories, okay? You have your white dwarfs, your main sequence stars, like our sun is a main sequence star because, again, it's the main star in our solar system. And then you have the giants and the supergiants and the nebulas and all of this. Now, all a nebula is, it's just a terminology for where that star is. So is it beginning life of its life, or is it towards the end of its life? Again, most of this you can get from the PowerPoint. So I would really encourage you to look at the main PowerPoints or that I just posted today. Another thing that you need to know for this unit is our description of galaxies. So if you look on the NASA website, and I gave you guys a bunch of links to different galleries on the NASA website, because those are trusted images. You know, those are verified images from astronomers, astrologers, astrophysicists. You know, those are verified images where if you look at stuff like on, you know, just Google or Wikipedia, that could be something that's photoshopped. The stuff that you're seeing on NASA are authentic images. So that's why I put those up there specifically. But when you look at those, we have a couple of different galaxies. You'll notice that NASA has very specific names for some. The main 3 you need to know, again, are spherical, elliptical, and again, irregular. Irregular just means it's not that circle, spherical shape, and it's also not that elliptical oval shape. So in case you don't remember, again, an elliptical, it's kind of more of this oval shape, kind of like this, and that's spherical one like we live in the Milky Way galaxy, it kind of has like a pinwheel sort of look and shape to it. So those again are the main three you need to know. Gravity still is out there in space. So I know we think of gravity as something that exists only on Earth, and that's not true. So whenever we have, again, all this gas and dust and all this stuff out there in space, whenever gravity condenses that and makes it close together, that's how we get stars and comets and asteroids and all of these other things. Gravity is literally what's holding those stars together. So we still have gravity even out there in outer space. Okay, it's just a little bit different than how it works here on Earth. Other than that, though, the bigger star you have, okay, the shorter lifespan, which I know is kind of interesting because we would think, well, the bigger it is, you know, the longer it would live, but it's actually kind of like the cliche, the bigger they are, the harder they fall, because the bigger the star, the shorter the lifespan. It's hard to maintain a life where, again, you have to have so much energy that's required just to keep yourself alive. So the bigger the star, the shorter the lifespan. Another thing that you guys need to understand is that it's kind of like the circle of life. You know, we're born, eventually we die, and you would like to think that whenever we die, maybe we get buried, then we are recycling and kind of being reused by the earth. Kind of like in the movie Avatar, when they bury things and then it comes back to their island in that way. It's kind of the same thing out there in the solar system. You know, when these stars do die and explode, they don't just disappear into nothing. You know, they're still made out of atoms, they're still made out of elements, and those elements eventually will get recollected back together by gravity, and again, maybe make a new star, maybe make, again, just something else to be reused by, again, the universe, the entire universe. So again, it's kind of just like when we think of our own circle of life, stars are just like that. They have their own circle of life that they follow, their own sequence, their own design. And there are tons of pictures, guys, of galaxies, of stars, of nebulas, of supernovas, and I mean, there's just, honestly, there's way too many to go through to share. So I really encourage you to go through those, you know, galleries yourself and look at those yourself, because again, there's just, I mean, there's billions and trillions of stars, guys. There's no way I can condense all of them into one PowerPoint. So please look at those, you know, sometime this week, hopefully. Another thing you're going to need to know is that because we're in 8th grade, we are using common names for these stars. You know, our North Star is actually Polaris, so that's what we call it. But again, there are other names for it, like C1735 and M27 and all these other terms basically that NASA uses. We aren't going to worry about those because they have those specific classifications for a reason, and I just really don't want to get into that right now. But they do have common names like Sirius. There is a Betelgeuse nebula that's out there right now. Again, Polaris and all these other names, a lot of Latin names, and you can even, there's a website where you can buy a star that hasn't had a name yet, and you can actually name it after somebody and give it as a gift to somebody. Again, all strange things that humans do, right? But let's see. I have a little checklist of things here that I'm trying to make sure I go over because I don't want to make this video too long. Let's see. But again, the one thing that I do want to talk about is these supernovas. And so I know that concept is kind of hard to grasp, especially because it's not something we can necessarily see from Earth. So I want you to think about when you have a bad day and maybe you've just had stuff piling on top of you and on top of you and on top, and then eventually maybe someone makes a comment and you just lose it. You just, and you kind of maybe yell, or you just, you know what I mean? You kind of go off, right? I think we've all been there at least one time in our lives. I know I have, okay? Well, that's kind of the same thing with stars, okay? When they basically get put under so much pressure from gravity that it keeps trying to condense and to condense, eventually that star reaches its capacity and it's like, I can't do this anymore. And you got to remember, there's still electrons and neurons, or not neurons, neutrons in there. So those electrons are going to repel one another. So if you keep trying to condense them, I know I showed you this with the magnets not too long ago, the more they repel each other, eventually they end up moving. So again, eventually they get put under so much pressure that they explode. And again, that's what we refer to as a supernova. You'll see, again, there's tons of pictures of it, but it's the same idea of just someone being under too much pressure and then having this big explosion. But again, all of that stuff can be reused by the universe. So even here on Earth, we have, iron and nickel and copper and golds and all of these metals and elements that occur naturally here, and it's because we found them from another place in the universe. And whenever Earth was finally forming, and I know I've showed you guys a couple of videos on this, all of those elements condensed to Earth, and now that's why we have them here. So you are literally made up of stardust, and whenever, eventually after you have a very long, long life, you will turn back into stardust, and that's something that Neil deGrasse Tyson talks a lot about. And I really encourage you guys to look up some videos and some documentaries on your own. It is extra credit for this class. In case you haven't seen that, go to Google Classroom and there's an assignment and it says extra credit, and there's a couple things on there for you guys. One of the ones I recommend for this unit is actually on Netflix, and it's a series, and the series itself is called The Universe. And there's 2 episodes in there. One is called, it's just over stars. I believe it's episode 9 and 10. And then there's another one that has to do with galaxies. So I would really recommend you watching those 2. I was going to show them to you in class anyway. You were going to watch them at one point. So if you have time and you have a Netflix account, again, I really do encourage you to watch those 2. Let's see. So I know I mentioned that. Let's see. Another thing I want to mention about that supernova and how it kind of, again, goes through that explosion process, it kind of ties into other things we've learned about this year. So whenever we learned about Newton's third law, okay, for every action, there is a reaction, okay? We talked about the balloon and how when we air it up and when we let the air out, so on and so on. Well, it's kind of the same idea. You can't just expect all of this pressure to go on that star and then it's just going to collapse and cave. You have, again, an equal reaction to that action, which again results in that huge explosion. So again, we have other areas of science that tie into this, but again, I am no astrophysicist. I do not know all of the math that's involved. I know you guys watched Hidden Figures in Miss Pena's class. Y'all saw how much math was in there. Again, I don't know everything. So again, if that is something that interests you, I encourage you in high school to take an astronomy class or an astrology class where you can learn more about this stuff if this is something that, again, you find interesting. And let's see, there's a couple other things. Okay, let's see. I know I mentioned that. Another thing that I want you to remember that you will see in that video is white dwarf stars are actually what we like to think of as retired stars because they have already gone through their process of death. They are actually just kind of waiting for that whole long process to actually die out. So that was just something that, again, is kind of interesting to think of. White dwarf stars, they are retired. But other than that, I really hope you guys use this time, especially since you are kind of stuck at home right now, to really look outside, okay? Look at the stars, look at these planets, try to understand your place in the universe, okay? Because even though you are made up of trillions and trillions of cells, even without one of those, you would not be complete. You would not function the same way. So even though we are only one human on one planet in one galaxy, we still, again, had to go through that whole process of our parents finding each other and all of this whole long thing just for us to be born. And so we are, in a way, not insignificant compared to, again, just the vastness of the universe, but we're actually necessary. You need us here to be on Earth and to be, again, in existence in order for Earth to work how it does. Because, again, you can't just, again, we've gone through this in class a million times, you can't just add something to the Earth and expect nothing to change. It will change, just like you can't remove anything from Earth and expect nothing to change, because it does. It can and it will, and we've seen this firsthand a million times. So I really hope this has clarified some stuff for you. At this point, if you still have any questions over this unit, please comment so I know what to do. Do you need more assignments? Do you need more PowerPoints? Do you need more pictures? Do you need more video links? Let me know what you need. Again, if these videos are helping, awesome. If you would rather me just record audio over a PowerPoint, that's fine. It does not matter, but you guys have to be the ones to let me know, okay? If you would, I know Miss Pina did a Zoom session today. If you feel like you need a tutoring session, that's fine. Just give me the information ahead of time so I can get as many people in there as possible. Again, just email me if you have any questions or concerns at all. And again, I'm here, so I'll see you guys soon.